Hello, welcome to today's class. Today I want us to veer off from the usual topical lessons. Today I want us to look at 2025 Physics Pre-Practical. With this we mean the anticipated practical experiments that we should be expecting for this year's WAEC. Now, one of the topics students find difficult during practical is electricity. And in electricity, once something like this comes up, potentiometer or meter bridge, students are always scared of. Now, with this lesson, we are going to simplify these topics so that the moment you see it in exam, then you will relax and then take your exams. Now, before we proceed, if you have not subscribed to my channel, if you are a new viewer, please hit the subscribe button, hit the like button, and then share this video with your friends. If you have a platform, please share it in that platform so that once students go into exam hall, they will go into exam hall with confidence. Now we go. We have this diagram on the board. Anytime you see this type of diagram, it means that this is a potentiometer. Now once you see a line marked X, Y, or it could be designated with any letter, it is your potentiometer. Now after this, I will show you all these apparatus one by one. So this line is a potentiometer wire. That's a thin wire. Now here, of course, E, this means the source of electricity, which is our electromotive force. Now we have this as a resistor. It could be a standard resistor. By standard means the resistor will mean a known single resistor. That resistor could be 1 ohm, 2 ohm, 3 ohm, 5 ohm, 10 ohm, as the case may be. It is labeled as R. I will also show us. Now this is the key, which is the switch. Now this is the potentiometer wire, just a straight line. From the one end of this potentiometer wire, we have our voltmeter, and from here we have the jockey. Now we go. The first question says, connect the circuit as shown in the diagram above. One thing with physics practical is very easy if you can heed to instruction. Because once you follow the instruction step by step, you must get your answer. Now they say connect it as shown below. So you don't need to swap anything. Maybe if you're a first timer, you can connect from one end of the potentiometer. From there, connect the EMF first. From the EMF, you get to the resistor. From the resistor, you get to the switch. From the switch, you get to the other end of the potentiometer wire. From this end of the potentiometer wire, connect straight to your voltmeter. From your voltmeter, connect your jockey. Now the second instruction says, close the key. After you must have connected your circuit, they said close the key and use the jockey to make contact with the potentiometer XY. So anywhere you make contact on this wire, at a point say that L, this length here is equal to 15 centimeters. So L is equal to XN, and it is equal to 15 centimeters. I'll also show us. And the third one says, read and record the value of the potential difference V on the voltmeter. Now the next question says, evaluate L inverse and V inverse. Repeat the procedure for 5 other values of L equals 25. That means at this point now you increase your jockey 25, 35, 45, 55, and 65 centimeters respectively. Read and record the values of V and evaluate, we have these V inverse and L inverse in each case. Now we have here number 5, instruction number 4 says plot a graph of V inverse on the vertical axis against L inverse on the horizontal axis. V, sorry, this thing should be V, please. Okay, it's correct. Determine the slope S of the graph. Evaluate K equals inverse of, this is 1 over, not L. Inverse of the slope. After you have gotten your slope, get the inverse is equal to K. Now, state 2 precautions taken to ensure accurate results. State 4 factors on which the resistance of a wire depend. If you can get this thing correctly, you are sure of at least 23/25, because you must answer 2 questions. Please, one of the things you must take into consideration is your timing. You modify so that that time, that 2 hours will be enough for you to do the 2 practicals and then plot the graph and make your necessary deduction. Do not waste your time on a question that you are not too comfortable with. If you're not too comfortable with the first question, there are options. You can move to the second one or to the third one. But with this now, this is the number 3, which is the electricity. I'll also draw videos on the other ones. Having gone through the questions or the instructions, let us now face the practical that we have. Apparatus one by one. This is our battery. Of course, the battery must be in a battery rack where you have a negative and a positive. You have your wires. Now, after that, we have the resistance. Of course, if you look at these now, it is this is the standard resistor. It is marked P. It is marked P. Remember, they'll always ask the person providing the materials to mask it and label it. So if it is labeled, please use accordingly. So if you unmask it now, you can know the value. So like I said, this standard resistor, it can come in different shapes and different sizes. We have a 1 ohm, 2 ohm, 3 ohm, 5 ohm, 10 ohm, 7 ohms, as the case may be. Now, after that, we have the switch. And of course, this is our switch. This is a two-way switch. By two-way, that means we can use this. That means you can connect here and here. These are the 2 terminals you can connect. At the end of the day, we use this. That is a switch. Now, if they say open, you open it. You can also use you can use this or this. And when you use these 2, you can now switch like this. Remember, while making your connections, make sure your keys are open. Now, the next one is the potentiometer. This is our potentiometer. Remember, this is just the wire. This wire. So the potentiometer, the length is 1 meter. So if we take it like this, is also, of course, 1 meter. This is 90. This is 90. You can see 4 here, 5, 6, 7, 8, 9. The last one is somewhere here. Okay, so now this is where the 100th mark is written. Now we have the jockey. This is our jockey, and for the jockey, we have, this is the terminal. It has just a single terminal, which is here. Right, unlike the potentiometer, this is the positive terminal, while this is the negative terminal. Now let us connect. The first instruction says connect as shown above. Now we do the connection. Now the first instruction says connect you connect from here. Make sure it is tight, but don't destroy it. Now from here to the EMF. Now from the other terminal, of course I've connected it already. From the other terminals, you now connect to the standard resistor. So this is the standard resistor. Here and here are the terminals. So we open here and then make sure you wind the wire here, and then at the end of the day you bring another wire and do it here. Okay, from having connected this, we've connected from here. Now remember, this is series connection. This remaining wire, we connect it to the key. Now remember, like what we said, open the key. We open the key first and then fix here. I have done this. This one is done. Now get another wire, fix it here. Fix it here. The moment we fix this one here, make sure it is fixed. Now we have it here, having connected that. Now from the diagram, this remaining wire, we go to it will come to this terminal. Now if it comes to this other terminal, we open here. Okay. Now we have connected here. Now we go back to the other side. Of course, we have here. We connect the other wire. Remember, since it is coming from here, you can always remove this wire, join the two wires, and then the other one will now come to the negative of this potentiometer, of this voltmeter. If it comes to the negative of the voltmeter, we have it here. Okay. Now, what is remaining now is the positive terminal. Now, this positive terminal, remember from the diagram, it's from the positive terminal that the jockey will be connected. Therefore, we connect the other one first. We connect this. After connecting this, we bring our jockey. This is our jockey. Use a longer wire such that it can get to the other end of the potentiometer. Now we connect here. Lock your terminal. Now, having done that, your circuit is now complete. The circuit is now complete. What is left now is to follow the instruction that says, that instruction says, close the key. Now, this is our key. It says, lock the key. I now put this. Close the key. After closing the key, you can now come back. Let me place this here so that we can always see it. At least you can see this 10 here. You can see 10 here. You can see 20 here. You can see 14. You can see 15. So please, while connecting this, make sure the graduated side is facing you. You start from the 0 end and not from the 100 end. Now remember, the first one says, use this jockey to make contact such that from this end to this end is 15. Now, if it is 15, we have... Okay, now that we have finished, they said at 15. This is at 15. Once I tap this on 15, please check the reading on this. Now we have, this is 15. Our reading is, I'll tap it again. It is between 0.2 and 0.1. Therefore, the answer is, the voltage there is 0.15. We note it. So, when the length of the potentiometer wire is 15, the voltage is 0.15. Now, we note it. Now, the next one, remember they say at 25, this is 25. Now, at 25, we tap here. The moment we tap here, this one goes to 0.3 volts. Now, after that, we move to 35. This is 35. If you tap it at 35, it is between 0.4 and 0.5. That means you can have it at 0.45 or 0.44, as the case may be, because it's more. Please try to observe parallax error. Okay. Now we take the next one. The next one is 45. At 45, we observe that this is 45. If we tap at 45, this is 0.55 volts, because it's more than 0.5 and it's less than 0.6, so it's 0.55. Now we move to the next one, which is 55. Let me shift my camera so you can always see it. At at 55, we have this as 0.65. We note it. And we can now take 0.65. 0.65, we have it as as 65 cm. We have 0.5, 0.6, 0.7, 0.8. We can also continue. If we continue at 75, we can have at 75. So at 75, we have it as 0.95. 0.95 is not up to 1. 0.95. Now at 85, you can have it as 1. It's not up to 1.5, 1.1. It is 1.05. 1.05. Now at 95, you can have it as 1.2 volts. Let us take our time now, having taken our readings. Let us take our time to do our table. Remember, they say tabulate your readings. So if we now tabulate our readings, I'll bring it up for us, so that from there we pick it up from there and then do our plotting. Have itemized all the parameters measured. We have the length, we have the voltmeter reading, inverse of the length, and the inverse of the voltmeter reading. Leave this column, I will explain this one later. Now, the first thing you do is make sure you record all your values to the appropriate DPs. For example, these are measured values. You read them directly from a device. That is why you are recording them to at least 2 DPs. Now, this one is evaluated value. This and this, inverse of a number. That is why we have it 3 DPs. Should you have just 2 DP, please use 0 to complete it, because inconsistent DP will attract loss of mark. Now, let's go to this column. This column and this column, they are the same thing. The difference is that this one is in standard form. I intentionally put it in standard form because these values are very low values. 0.065, 0.040. Now, to plot these, if you discover that if you can plot this as it is, feel free to plot it. If not, put it in standard form so that it can now give you a manageable figure. For example, this one that is 0.065. If you put it in standard form, we'll have a times 10 to the power minus 2. Because it's times 10 to the power minus 2, everything in that axis must be times 10 to the power minus 2. So that if you look at this now, this is a manageable figure. So you can plot 6.5, you can plot 4.0, you can plot 2.9. Okay, so I'll tell you how to indicate this so that you don't end up writing times 10 to the power minus 2 in all the values, all the column you have there. Now, other things you need are, you have this, you must use sharp pointed pencil. This is your... So I want us to plot the graph of what we have just done. I would have used the normal graph sheet to do the work, but because of illustration sake, I am using this. All you need are, if you are going to the exam hall, please use this type of ruler. Do not use the other one, because this transparent ruler will give you aid if you are drawing your line of best fit. Now the next thing, you must use sharp pointed pencil. No dirty work, let your work be neat. Now we will start. But before we start, please, for details on how to plot your graph, there is a link down below. Click on that link and then study how to plot graph. We are just going to plot this graph. I'm not going to teach you how to plot. Now we start. This is the graph sheet we have here. I have already ruled the vertical axis and the horizontal axis. Remember, the question says plot a graph of V inverse against L inverse. All you need to do is to represent it. Here we have V inverse. You don't just write V inverse there. You put the SI unit minus V inverse or pivot. Now on this axis, you have it there, inverse of L. You put the SI unit there per cm. Remember, okay, we'll get to that later. The next place is here. Please, if you are asked to plot any graph, unless you are not told, always start your graph from the origin. Now indicate it here. Here I have 0, 0. This thing is very important. This is 1 mark, 1 mark, 1 mark. On no condition should you skip the SI unit on this axis, and on no condition should you as well skip the SI units on this axis. Now, having done the axis, the next thing now is to pick our scale. Now, to pick your scale, all you need to do is to go through your work, find out the highest score. The highest value you have should occupy at least 2/3 of your worksheet on this axis. It should as well occupy 2/3 on this axis. Now let's start. On the V inverse axis, the highest score there, the highest value you have there is 6.6, otherwise 7. Now, if you read this, it cannot maybe, of course, this thing presumably should be 2 cm, but because of this is a reduced graph, so I can use this. From your own graph, the graph is graduated in 2 cm, that is 10 blocks. From here to here is 5 blocks, but the graph you are going to use has 10 blocks, so use it. Now, I can have here 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0. Assuming I don't have this, please make sure you fill all the values there. Don't just stop at the last value. Fill it up. Now I can still have here on the horizontal axis, I have that the highest score there is 6.5. While the least is let's say 1.3. Now if it is 1.3, I can have 1 here the same way, 2 here, 3 here, 4, please, this is 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, here is 7.0. So always note that yes, there is a mark, there is a scale here. This one should be somewhere there. I intentionally brought it back so that it can occupy that. Remember, you reduced this, you put it in standard form. You must indicate that this thing is in standard form. You say times 10 raised to power minus 2. So this times 10 raised to power minus 2, very important. So that all the values you have here, you multiply them by times 10 raised to power minus 2. Now, having drawn our scale, without wasting time, we plot. Now, the first one says, now let us read this. If it were to be normal graph in the sheet, this one should be 10. But this my own now is 5. So from here to here is 5. What it means is that this one is 0.2. This line is 0.2. So I have 0.2 here, 0.4 here, 0.6 here, 0.8 here, 1.0. 1.2, 1.4, 1.6, 1.8, 2.0. This is my own. Your own should be 1.0, 1.1, 1.2, 1.3, 1.4, as the case may be. Now, I want to plot a graph of 6.67. If you approximate the first one, it will give you 6.7. You are going to plot 6.7 against 6.5. Now, let's take it. This is 6. 6.2, 6.4, 6.6, 6.8. Now 6.7 will be in between these lines. Now you can trace it. Please, on no condition should you draw. Please don't make the mark. Just locate it and then mark it. This side here is 5, here is 6, here is 7. Now 6.2, 6.4, 6.6, 6.5 is in between. Now you trace it. You trace it up. If you trace it up here, this one is here is 6.2, 6.4, 6.6, 6.7. Now somewhere here in the middle, you make your mark in the middle. Now the next one is 3.3 against 4.0. Now this is 3.0 here, 3.2. 3.3 is in between these two lines. So please, I can't remove that in. So this is 3.2. 3.3 is in between. Again, so you trace this here, or I can still, because this is my graph, I can trace it against 4.0. That is somewhere here. Then you make the mark. If you make the mark, for me, I will clean these traces. Leave no traces on your graph, please. Now, the next one is 2.3. Round that number up. 2.3 against 2.9. Now, 2.3, this is 2.0, 2.2, 2.3. Somewhere here, I can take it 2.3 against 2.9. Now, this is 3 here. This is 2.8 here. 2.9 is in between. So I can now make it here and then clean here. If I clean here, what I have there. Now the next, which is the fourth one, 1.8 against 2.2. Now this is 1.2468. 1.8, this line against 2.2. So this is 2. 2.2, that means it will be somewhere here. That is why it will be. Now the next one is 1.5. against 1.8. This is 1.2, 1.4. 1.5 is in between against 1.8. That means somewhere here. Somewhere here. And I will clean off this side. Now, the next one is 1. 1, 2, 3, 4, 5. Now the next one is 1.3 against 1.5. 1.3 against 1.5. This is 1.2. So 1.3 is in between here. Now 1.3 against 1.5. Here is 1.2, 1.4. 1.5 is somewhere here. Now if you trace this one here, trace this one here, now you have a meeting point at the middle. I can now erase here and erase this side. Now the last but not the least, remember they asked us to stop at 65. I intentionally brought it to 75. Now which is 1.05. That 1.05, make it 1.1. 1.1 against 1.3. So this is 1.1. 1.1 is just here against 1.3. This is a 1.2. 1.2, 1.3 here. You retrace it and trace this here, and they will meet somewhere here. I'll clean this and clean this. I have done, this is the graphing. The next thing now is to draw my line of best fit. That is where this thing comes into play. If you are to do this in your notebook, use this transparent ruler. But I'm going to use this ruler. Now, draw your line of best fit. Remember the rule. Since there are 1, 2, 3, 4, 5, 6, 7 plotted points, if 3 enters or 4 enters, the remaining 3 will be distributed above and below the line of best fit. So don't just drop your disc. Let me show you what you mean by that. Assuming if I do it like this, all of them cannot enter. And if I should take that one and this one, we have 2 will enter, 5 remain. 1, 2, 3 will be one side, 2 will be the other side. Now I can still get better ones. So if I place it like this, I can now get 1, 2, 3, 4. 5. 2 will be left. 1 will be that side. These 2 will come down. Therefore, I can now draw my line of best fits. So if I draw my line of, this is my line of best fits, you can continue this line, fill your workspace. This is the graph I have. You can also bring this one so that if you are asked to get the intercept, you can always get the intercept. So that is why I advise you to use a longer ruler. But now with not this, at least the transparent 30 cm ruler can get a straight line without cutting it. Now having done it, the next thing now is to draw our triangle. Remember, the triangle must be a large right-angled triangle. Don't hang it, start from anywhere. Whether there is a plotted point there or not, you can start from anywhere. Now, if I should start from here, I can now bring it up to here. If I should bring it up to here, this one, you can use dotted lines to bring this one. So this is where my graph, my triangle is. Now I can also draw this horizontal one. This horizontal one, I can have this. So if I have this, I can, just to embellish it, even though it doesn't carry any mark, I can use the dotted lines to bring this one down. I can also use dotted lines to get this one up to here. I can as well use dotted lines here to get this one up to here. So if I use dotted lines here, now I can label here change in whatever I have on this axis. So on this axis, delta, what you have here, V inverse. Now this side, I can have delta, on this axis, I can have delta L inverse. Here is delta V inverse. Now for the slope, permit me to write here, but on no condition should you write on the graph sheet. Now the slope will give us change in what you have here, V inverse all over change in L inverse, which will give us, now V inverse, this is where the slope started. Remember, it is somewhere here. You read it up to here. This is 5.0, 5.2, 5.4, 5.6. That means 5.6 minus the down one. The down one is 2. 2.0 all over what you have here. You read it. Here is 7. 7 minus here. This is 2.2, 2.4, 2.4, which will give us, by calculation, we have 5.6 minus 2 will give us 3.6 all over 7 minus 2.4 will give us 4.6. Remember, you did some calculation here. So bring it times 10 raised to the power minus 2, which will give us 3.6 all over 4.6 times 10 raised to the power minus 2 will give us 0.046. Now 3.6 divided by 0.046, and it will give us 78.3. 78.3. It must have a SI in it. This one is in per volts all over. This one is per cm. All over per cm. So we now have that the slope is 78.3 per volt. The SI unit of the slope is, of course, the slope is 78.3 per volt per cm. That is the slope. Now the next question says evaluate K is equal to 1 over slope. K is equal to 1 over slope. You write the formula first. It has mark, which is equal to 1 over this value, 78.3, which will give us, and 1 over 78.3 will give us 0.013. 0.013. Please, I will clean this. 0.013. And this, because this is inverse, it will knock off this one, knock off this one. It will now be volts per cm. Volt per cm. That is the value. Now, the next question they ask us here is to state 2 precautions taken to ensure accurate results. Now, for those precautions, I will give you more than 2 precautions. Anyone that you remember in the hall, please write it. Number 1, you can say, I noted and corrected 0 error of the voltmeter. You can also note and correct 0 error of the potentiometer. Now, we said, I avoided error due to parallax. While taking my readings, you call that place. If you are taking a reading from the potentiometer, you say it. If it is from the voltmeter, you say it. So you avoid error due to parallax while taking your reading from the note the particular place. Next one, I gently tapped the jockey on the potentiometer wire to avoid scratching it or increasing the temperature. So you don't drag it, you tap it gently. Now, next one, I ensured that I switched off, or you say, I switched off the circuit when the reading was being taken to avoid running the battery down. Next one, I ensured tight connection of wires to avoid voltage fluctuations or current fluctuation. Now, the last but not the least question says factors that affect resistance of a wire. We have about 4 of them. One, we have temperature. Temperature varies directly with the resistance. That means the higher the resistance, the higher the temperature, the higher the resistance, and vice versa. Two, area of wire. The resistance of a wire varies inversely with area. That means the thicker the wire, the lesser its resistance, and vice versa. You can have length of wire. The shorter the wire, the higher the shorter the resistance, please. While the longer the wire, the higher its resistance. That is why resistance varies directly with L. Last but not the least, nature of wire. If the wire is made of silver, silver is the best wiring material, followed by copper and aluminium. So silver is the best. It depends on the nature. Now, please, for more information, follow me on my social media handles. If you have not subscribed to this channel, please hit the subscribe button and share this video with your friends. I will see you in my next video, where I will be bringing you with a live question for 2025 WAEC question. See you then. Thank you.